All right, question number 4. It says, suppose the position of an object moving horizontally after t seconds is given by the following function, s of t. S is measured in feet, greater than 0, corresponding to positions to the right of the origin. We're going to graph the position function. We're going to find and graph the velocity function. We're going to answer when is the object stationary, when is it moving to the right, to the left. We're going to determine the velocity and acceleration of the object at t equals 1, determine the acceleration of the object when the velocity is 0, and then on the intervals, on what intervals is the speed increasing, decreasing. So we have our position function, f of t equals t squared minus 6t, and this is going to be from 0 to 7. First we're going to graph that. So we do know that this function is a parabola. So there's a couple things we can do. F of t equals t squared minus 6t. So I just, based on the algebra of it, we do know that this is a parabola. It's opening upward because the leading term is positive. We can find the center point. I would definitely say that by process of elimination we can get rid of answer choice A and answer choice D. So basically we just need to find the vertex. So just using algebra, negative b over 2a, that will give us the x coordinate of the vertex. B value is negative 6, so a negative 6 will be a positive 6 over 2 times 1, and this will give us 3 for our x coordinate. If we plug in 3, (9 minus 18) gives us a negative 9. So we're looking at the order pair 3, negative 9 to be our center point. We'll just call this 9. So looking for my parabola to kind of be going that direction. And the closest one, because it's opening up to that, would be B. All right, velocity function is going to be f prime. Derivative 2t subtract 1, this gives us 2t, and then times 1 is a negative 6. So our velocity function is 2t minus 6. If we were to graph the velocity function, this is a positive slope, y-intercept of negative 6. So 1, 2, 3, 4, 5, 6. Start down here, and we will go up 2, right 1, up 2, right 1. Okay, so we're looking for a line that looks like so. C, only one that has that negative 6 is intercepting below the line and going up to the right. When is the object stationary? Well, you set the derivative equal to 0. That's when we come to a stopping point. So when is the velocity 0? We'll find v of 0. That will be 2 times 0 minus 6. Sorry, I'm plugging in time 0. When is the velocity 0? I want to set v of t equal to 0. So that is 2t minus 6 equals 0. Add 6, 2t equals 6, divide by 2. velocity is 0 when t is equal to 3, when time is 3. That should also kind of correspond to the x-intercept when it's crossing the x-axis, being at 0 when t equals 3. The object is moving to the right on blank. So again, up here it told us that the position function s is measured in feet, and with s greater than 0 corresponding to positions to the right of the origin. So that's just position. We are asking, the object is moving to the right on which interval. So it looks like we have, back to our position function, since it's negative, looks like it would be going left, and then positive would be going right. That also corresponds to your velocity function. Below the x-axis is negative, but when it's above, it's going right. So from 3 to 7, that's our range, from 3 to 7. Since 3 was a stopping point, we're going to put that in a parenthesis. So 3, comma, and then we'll do 7. We'll put that in a bracket because it's still moving to the right at that point. It just goes up to 7. The object is moving left, so that again corresponds to the negative slope, the part that's below the x-axis. That's going to be from 0 until we get to 3 where we stop. So it looks like this graph is going to the left, negative slope, going back, and then stops, and then starts going right. So this is as time goes from left to right. So it is moving left from 0 included to 3, and then I'm not including 3 because that was a point where we stopped to turn around. The velocity of the object at t equals 1. So we have our velocity equation. We're going to plug in 1. V of 1 is 2 times 1 minus 6. 2 times 1 minus 6. 2 minus 6, negative 4. So at time 1, velocity is negative 4. And that should be feet per second. Time is measured in feet. Yeah, feet per second. The acceleration of the object at t equals 1. So we're going to take the derivative of the velocity function. That's going to give us acceleration. So velocity function was 2t minus 6. Derivative of that times 1 would just give us a 2, and then derivative of 6 will give us 0. So acceleration, a of t, or a, is just equal to 2. Plugging in a 1, we don't get anything, we just get 2. It's 2 the whole time, so our acceleration is 2. And the second derivative is in square units, so 2 feet per second squared. The acceleration of the object when the velocity is 0. So they're just asking, what is acceleration when the velocity is 0? Well, the velocity was 0 at t equals 3. So if we just plug in a 3 here, we still just get 2. So it's still 2. Don't have a variable to plug in. And it's feet per second squared for acceleration. And then when is the speed increasing? So the speed is the absolute value of the velocity function. And so if we look at the velocity function right here, and we do the absolute value, this graph, instead of going up like so, it's going to come and mirror image right here. and we're looking for the line when it is positive slope. So this is a negative slope. This is a positive slope. So we're just focusing on this part right here. We want to know when the speed is increasing. So we will say the speed is increasing on the interval from 3 to 7. I think we still use a bracket, 3 to 7. And it wants us to graph the position function. Choose the correct graph below. I'm sorry, this is the new question. That was it.